In this video, I'm going to show you a special product situation. So sometimes if you can see the pattern and remember the pattern, you can do a shortcut. So this one here actually allows you to do a shortcut. So I'm going to show you the shortcut, and I'm going to tell you that this is the first time that I'm actually going to teach you a shortcut, and not and if you remember it, you can do it. So remember that this is a binomial times a binomial. So we're going to set this up as we normally do when we multiply. So this is A plus B. Don't get freaked out that there are no numbers there. It doesn't matter. It's all about the process. That's what Algebra 2 is about. It's being able to conceptualize and generalize. So that's what we're doing. So A times A is A squared. A times B is AB. A times negative B is negative AB. Notice that they're together, they're multiplied. B times negative B is negative B squared. Okay, so let's look here. There's my peanut of math. So when I go to write this out, I get A squared, negative AB, and positive AB gives me 0. So that's gone. That turns into a 0, and then I have a negative B squared. So what I have here is I have the product of a sum of difference of binomials. And this here is something special, and we'll look at a shortcut with this later. But this here is called the difference of squares. Okay? So the difference of squares. Why? Because this is a square, and then we're taking the difference of another perfect square. Okay, let's do this with numbers. So let's say I have x minus 4 and x plus 4. Okay, so you can see how this is similar. I just put minus, my minus term first and my addition term second. It really doesn't matter. So here I have x minus 4 and x plus 4. So we're going to see the same pattern's going to hold, and I'll do one with the shortcut. But when there's a shortcut, you have to, it only works for this. It doesn't work for any other one. Okay, so you have to be careful. So x times x is x squared. Negative 4 times x is negative 4x. X times 4 is 4x. Negative 4 times 4 is negative 16. So once again, we're going to look at our peanut. Oh, look at those. Those are opposites, aren't they? So I end up getting x squared minus 16. Again, the difference of squares. So this here is a perfect square. So is 16. This is the same thing as saying x squared minus 4 squared. So again, it's the difference of squares. So that's a very special pattern. So let's do one with the shortcut. Again, you can only do it if it has this pattern. I can't stress that enough. So let's do something really crazy. Let's do something like 3x plus 5 times 3x minus 5. Oh, let's even put a y in there. Let's make it really crazy. Okay? So let's see. Does it follow the pattern? Well, this is like A plus, and then this here is like my B, isn't it? 5y. And then 3x is like my A, and my 5y is like my B. So we can see here that that's following the pattern. So this is a shortcut. So notice what we did up here. We had a squared minus b squared. So let's try that. Let's go ahead and square the first term, because they're both the same. So 3x squared is the same as 9x squared. And 5y times negative 5y is negative 25 y squared. So that's the shortcut when we're multiplying. But we can only do that when our first terms are exactly the same, our last terms are exactly the same, we have a plus, we have a minus. That's the only time we can do this. So the one last thing I'm going to do is I'm going to prove to you that this is the answer by doing it the long way. 3x plus 5y, 3x minus 5y, I'm going to multiply. 3x times 3x is 9x squared. Oh, that's good. That's what I got there, right? 5y times 3x is 15xy. 3x times negative 5y, well, we're going to do 3 times negative 5 is negative 15, and then times x times y. And then 5y times negative 5y is negative 25y squared. So here is our peanut. We have xy terms. I have a minus 15 and a plus 15. Well, that turned into a 0. And then what am I left with? I'm left with 9x squared minus 25y squared. So that, if you notice that you have the sum and difference of the same exact numbers, you can do the shortcut.